to the learning zone. I'm Mr. B. In this video, I will explain how to calculate the pH of a 0.036 molar solution of hydrofluoric acid. Hydrofluoric acid is a weak acid. To determine the pH of a weak acid, the following steps should be followed. Calculate the pH of a 0.036 molar solution of hydrofluoric acid, where from a table of Ka values, the Ka value for the ionization of hydrofluoric acid is known to be 4.5 times 10 to the minus 4. The first step is to write the equilibrium equation for the ionization of the acid, where aqueous hydrofluoric acid will reach equilibrium to produce aqueous hydrogen ion and aqueous fluoride ion. The next step is to write an equilibrium expression based on the equation. The equilibrium expression is written as Ka is equal to the concentration of hydrogen ion times the concentration of fluoride ion divided by the concentration of hydrofluoric acid. Remember, in an equilibrium expression, the concentration of the products are always divided by the concentration of the reaction. The next step is to create an ice table. An ice table indicates the initial concentrations, the change in concentrations, and the equilibrium concentrations of all species in the equilibrium equation. The initial concentrations, or I, are 0.036 molar for the hydrofluoric acid, and of course 0 molar for both hydrogen ion and fluoride ion. The hydrofluoric acid is undergoing ionization, so the change in concentration is represented by minus X. As the reaction proceeds, the concentration of both hydrogen ion and fluoride ion are increasing. Therefore, these concentrations are represented by plus X. At equilibrium, the concentration of the hydrofluoric acid will equal 0.36 minus X. And of course, the concentrations of both hydrogen ion and fluoride ion at equilibrium will be represented by X. This data should be inserted into the ice table. Since the Ka value for our hydrofluoric acid is so small, we may now make a critical assumption. Let's assume that the value of X is negligible compared to the concentration of the acid. So at equilibrium, we may now write that the concentration of hydrofluoric acid is 0.036 molar. Now we have enough information to insert the equilibrium concentrations into the Ka expression. Remember, Ka is equal to the concentration of hydrogen ion times the concentration of the fluoride ion divided by the concentration of hydrofluoric acid. Therefore, 4.5 times 10 to the minus 4 is equal to X times X divided by 0.036. And of course, the expression may be simplified as X squared divided by 0.036. To solve for X, first multiply through by 0.036 and then take the square root of the product. X will equal the square root of 4.5 times 10 to the minus 4 times 0.036. This will equal 4.0 times 10 to the minus 3 molar, which represents the value of X. X also represents the concentration of both hydrogen ion and fluoride ion. The value of X is 4.0 times 10 to the minus 3 molar. Therefore, the concentration of hydrogen ion will also be 4.0 times 10 to the minus 3 molar. To determine pH, simply take the negative log of the concentration of hydrogen ion. Minus log 4.0 times 10 to the minus 3 is equal to 2.37. Remember that earlier in the calculation, we assumed that the value of X is negligible. Now we must check for the accuracy of that assumption. If making the assumption that the value of X is negligible is correct, then the percent ionization of the acid should be less than 5%. To calculate percent ionization, simply divide the concentration of hydrogen ion that was calculated by the initial concentration of the hydrofluoric acid times 100. This will equal 4.0 times 10 to the minus 3 divided by 0.036 times 100. Unfortunately, this will equal 11%. Therefore, the initial assumption was invalid. Since the percent ionization of a 0.036 molar solution of hydrofluoric acid is greater than 5%, then the quadratic formula must be employed to determine an acceptable hydrogen ion concentration and thus an acceptable pH value. In my next video, I will explain how to use the quadratic formula to determine the pH of a 0.036 molar solution of hydrofluoric acid. But for now, this concludes my video of how to determine the pH of a weak acid. Just remember, if the percent ionization of the weak acid is less than 5%, then your task is complete. However, in this particular case, the percent ionization was 11%. Therefore, the quadratic formula must be employed. Hopefully, this video has been helpful. Thanks for watching.